Welcome to the session on the innovative use of social media for remote sensing and the monitoring of the UN Sustainable Goals at the UN World Data Forum 2020. A brief introduction about the organizers. We are academics working on the use of social media for digital goods. Some of our research has pioneered the use of digital data for demographic purposes like migration and gender gaps. I am Kiran Karimella. I'm a postdoc at the Massachusetts Institute of Technology in the US. We also have Ingmar Weber from the Qatar Computing Research Institute in Doha, and Emilia Zagani at the Max Planck Institute for Demographic Research in Germany. The idea behind this session is to enable the flow of ideas about latest advances in academia in terms of various methods and applications using social media in non-traditional ways to a diverse audience. We bring together 5 experts from academia and government organizations working on cutting-edge research using social media in an innovative way to address some of these issues. The first is Dr. Stefano Cresci from the National Research Council of Italy, who will talk about how we can use social media to acquire information during a crisis and cleverly combine that with data from Twitter collected using crowd sensing. Next, we have Catherine Hoffman-Pham, who's a PhD student at New York University in the US. Catherine will talk about the use of Facebook advertisements as a way to survey respondents, especially in the global South with populations that have been hard to reach traditionally. Given the circumstances we are in with COVID, this is an extremely timely topic and provides evidence of how Catherine and her team were able to survey thousands of users in Mexico and Kenya. Dr. Setia Pranama from Statistics Indonesia will provide some really interesting examples on how his team was able to use various types of social media data, including Instagram and Twitter, to tackle a wide range of real-world problems in Indonesia, from traffic and commuting statistics to measuring the performance of the tourism industry to creating a happiness index throughout Indonesia. Professor Riddhi Kashyap from Oxford University will talk about the use of Facebook advertising data to study and measure the gender gaps in access to the internet all around the world. And finally, Professor Lisa Singh from Georgetown University in Washington, D.C. will talk about her work on predicting forced migration in Iraq using noisy signals from social media and other traditional sources of movement data like the UNHCR. So we have 5 amazing speakers, and as we saw, we have a mix of expertise covering various types of social media data, Facebook advertising, tweets, Instagram posts, from to cover a wide range of applications, crisis situations, surveying users at scale, measuring gender gaps, and understanding forced migration. See you in our session to learn more about these novel ways of using social media platforms and to hear from the authors on how you can use social media in your use cases. We're also conducting a live Q&A session with the authors on 19th of October at 11 a.m. Eastern Time. See you there.
Hello, everybody. I'm glad to have the chance to contribute to this very interesting session. I'm Stefano Cresci from the Institute of Informatics and Telematics of the Italian National Research Council, and today I'm going to talk about a solution that we developed with my colleagues at IIT CNR for increasing the quantity and quality of social media data. Before jumping to our solution, we all know that in social media, data is biased or skewed towards, for example, certain populated areas, like big cities where the population density is higher, or even certain topics. So the question that drove our work is whether we can leverage social media to obtain more information about underrepresented locations and topics, or even if we can get information that helps us verify claims for which we received contrasting opinions or corroborate other information. We know that there are mainly 2 ways for collecting data from social media. One of those ways is called the opportunistic sensing approach. In that way, social media users contribute data to the system, but they are unaware of the sensing system. So they basically share data as they go through their daily activities, and the system transparently collects that data. As a result, data collected with the opportunistic approach is unstructured and heterogeneous because it is not targeted to the system. And also because of this, there is the need to remove noise from this data, because not everything that gets collected in this way is actually relevant for the task. The upside of this scenario is that we have access to a large and spontaneous user base, because we don't need to motivate users into contributing data to our system. And so we have access to a large and fast amount of data. On the other hand, with the participatory approach, users are willingly sharing data with the system. So the data that the system receives is structured and homogeneous because it is targeted for the system. But we need to foster contribution from the user. So we need to motivate them into giving us, let's say, their data. So given these two orthogonal approaches, our solution aimed at combining these two techniques, and we came up with something that we call the hybrid sensing, which, as you can see here, is basically the combination of an opportunistic sensing phase, the selection of a subset of users from which to solicit additional information, and then the participatory sensing phase, where we contact those users and we ask them targeted questions and collect the answers that they give. So as I said, three main steps: collecting spontaneous user reports on a given topic. So for example, an emergency from which we want to obtain a higher situational awareness. Then selecting potential volunteers from which to solicit additional information, and stimulating contributions from those volunteers with the participatory sensing part. We implemented this kind of system in Twitter, and this is what looks like in Twitter. So basically, this creates kinds of conversations, let's say, where the topmost tweets in these conversations are the spontaneous messages sent by the users, followed by our question, and the bottommost tweets are the answers of the users to those questions. So the first tweet was collected with the opportunistic approach, and the last one with the participatory approach. And all together, this makes up the hybrid sensing approach that I was talking about today. The advantage here is that we can ask targeted questions to the users, soliciting, let's say, fine-grained information for specific issues that we want to discover. One key part of the system that I just showed was the step where we needed to select volunteers from which to solicit additional information. For example, in the case of emergencies that I showed before, it is important to be able to collect first-hand reports of what is going on. And to do so, we need to identify witnesses of the emergency, so people that are directly involved in it. We did this, we achieved this goal by designing and developing a witness detection system. This task is not particularly difficult if we leverage state-of-the-art natural language processing techniques and machine learning. The difficult part here is obtaining an accurate and high-quality ground truth to train the classifier, the witness detection classifier. And since this ground truth was lacking at the time that we studied this, we decided to create our own ground truth for this task. And we created this ground truth by leveraging the same hybrid sensing approach that I just showed you. So we let the users, let's say, automatically label their own messages as to whether they were sent by a witness or by a known witness account. So for example, we were, in these examples right here, I'm talking about a film festival that occurred in Italy. Again, we have some users tweeting about the festival, spontaneously tweeting about the festival. That's the topmost tweets. Then we ask our question, and we ask users whether they're physically attending the festival or whether they're tweeting about it from somewhere else. And in the bottommost tweet, users answer to our questions, and they tell us, yes, I am here, so I'm physically attending to the event, or not really, I'm not here. And in this way, we use the third tweet to label the first one from the user. So we know that the first one on the left was a tweet from a witness account, and we know that the first tweet on the right was a tweet from a non-witness account. In this way, we built our ground truth, and we used it to train a witness detection classifier. Okay. Now we can combine this witness detection module together with the hybrid sensing system that I showed you before. And we obtain this system right here, which we used again to better study and to collect additional data in the aftermath of mass emergencies. So again, we start with an opportunistic sensing phase where we collect spontaneous user reports on the emergency. We filter out noise. Then we apply the witness detection module that I just described. At this point, we have accounts that are labeled as witnesses, so we know that they are on the ground. We have the information needs of emergency personnel, and we can ask targeted questions to the witnesses in order to satisfy the information needs of the emergency personnel. We do this in the participatory sensing phase. We collect user replies to our questions, so replies that provide us with additional information. And then from now on, we can do a few different things. So for example, we can look for damage reports within those replies. We can also try to extract additional geographic information from those tweets, all, for example, with the goal to put those information on a map and plot some crisis maps of the unfolding situation. So, till now I talked about event attendance, so witnesses, and also situational awareness with the emergencies, but we actually used this system also in other scenarios for other experiments. So for example, we asked people to solve CAPTCHAs for us in order to verify that the accounts were, let's say, human driven and not software driven. We also asked people to give us some insights into different and similar products, which one they were preferring, which one they would buy. And also we asked for electoral forecasts. By experimenting in all these situations, in all these scenarios, we came up with a few interesting conclusions and results. The first one being that when users are involved with the topic that we want to talk about, that we ask them about, we receive the highest percentage of answers from our questions. So, for example, in emergencies where involved users are also emotionally involved in what happened, we can obtain up to 30% answers for our questions. For other events, such as politics or general attendance to other events, we receive a slightly lower response rate. And then for other topics like CAPTCHAs, for which people are not really interested in, we obtain answers in the region of 10%. So let's keep in mind that all these answers that we obtain, even if they are, let's say, 10%, a small percentage of all the questions that we ask, this is not bad at all anyway, because this system is fully automatic, so we can send out thousands or tens of thousands of questions automatically. And so even 10 or 30% of those questions getting answered still represents a quite significant amount of data. On top of that, we also manually labeled the answers that we received, and we found out that around 75% of those answers were collaborative. So people actually answered our questions and provided help and useful information to us. So 75% of those answers, we can use them for further analysis, while the remaining part are mostly ironic. So people replied to our tweets, but they did not really answer our questions. They made irony and comic comments on the fact that a bot was contacting them and asking them questions. And also a very small percentage of users was bothered by our system, and they did not want to be disturbed by us, let's say. So those 25% of answers are, of course, not much useful for further analysis. A few other interesting insights into this experiment. We noticed that the probability of receiving an answer strongly depends on the delay with which we ask our question. So if we ask our question in less than 30 minutes from the user's original spontaneous tweet on the topic, we have that 30% chance of receiving an answer. While if we wait too much, if we wait more than 30 minutes from the original tweet with our question, then the percentage of receiving an answer, the probability of receiving an answer, rapidly decreases. And for example, after 1 hour from the original tweet, there's almost no possibility to obtain an answer from a user. So we should act fast. And also, we wanted to investigate with how much delay the users actually answer to our questions. And we found out that the vast majority of answers to our question arrives in the first 5 minutes from our question. So time is very important. We need to be fast both at asking questions, and we can expect that users will be fast at answering those questions, which is good also in time-sensitive cases like the emergency scenario that I showed before. One final note, the system depends on automated social media accounts for asking questions. And we know that social media platforms are now quite focused on stopping spam and stopping social bots, automated accounts, and all this kind of stuff. So asking too many questions in too little time will get the accounts banned. And also tweeting the same message over and over again. So for example, asking the same questions with the exact same words over and over again will make it so that the account will not be able to tweet anymore. So we have to take this into account when we consider the scalability of this system. And actually, it would take many automated accounts that would be needed for being able to send out tens of thousands of questions in a limited amount of time. But however, all these things that I showed you, we obtain them by only leveraging public Twitter APIs. So there's probably the possibility to make deals with platforms, especially for humanitarian purposes, in order to raise these limitations and to be able to send out more questions in a limited time. Thank you. It was a pleasure to contribute to this session. Thank you for having me.
Hi everyone, my name is Catherine Hoffman-Pham, and today I wanted to talk about our project on survey sampling in the Global South using Facebook advertisements. I'll note that this is a project that's joint with collaborators in political science and demography, and I myself am a PhD student in information systems, and so I think this highlights sort of the diverse appeal of these methods across a variety of disciplines. And in particular, I'm hoping that many of you who are joining for the World Data Forum will be interested in the potential of online platforms for survey recruitment. So I'll start with the motivation for our research, which is effectively the observation that traditionally most survey samples have been collected in person. And this can be sort of a time-consuming and expensive approach to collecting data, but it can yield very high-quality results. More recently, people have started using online surveys, which are fast and often very affordable, but there's less information about the quality of the responses collected using online survey tools. In particular, we've seen that researchers are using Facebook as a survey recruitment tool. On the one hand, the platform has a very large audience, about 2.5 billion monthly active users as of September 2019. And on the other hand, the Facebook advertising platform allows for micro-targeting of certain demographics with Facebook ads. And so researchers have used this to reach sort of narrowly defined populations. For example, one paper looked at reaching Polish migrants living abroad. Another targeted specifically East African respondents. And in recent months, people have been using the Facebook platform to study COVID-19 behavior in different countries. And so I think in particular, these platforms are a really promising strategy, in this sort of pandemic age where you might not want to go and have face-to-face contact with your survey respondents, but at the same time, you might be really interested in collecting real-time data from people in a diverse set of locations. So there has been a little bit of research so far on the use of quota sampling via Facebook advertising, and in particular, one study in the US found that using quota sampling, you could actually reconstruct nationally representative opinion surveys. However, it's not clear whether this strategy can succeed in the Global South, where Facebook penetration is much lower. So when we think about collecting quality samples, we sort of thought about this along two main dimensions. The first is internal validity. And so this is a question about, the quality of the responses collected in the survey. We want to know, does Facebook effectively target respondents with the characteristics that we're interested in? And then given that we have these responses, are they actually valid? Are people paying attention? Are they giving truthful answers? Second, we wanted to look at external validity. So given that we've collected a sample of responses on Facebook, do these results generalize to a broader population? And in particular, is there some sort of unobserved selection bias in the type of people that we're able to recruit? So we decided to collect data from two main case sites. The first is Mexico, in which about 87% of people are on Facebook. And when we collected data on the Facebook platform, we targeted people using a strata according to their gender, their age, and their administrative unit, the municipality in which they live, which you can see sort of plotted on the bottom here. We also added a supplementary sample of people who were targeted from among the education categories that were less represented in the original sample. The survey focused primarily on questions about climate change and recruited about 5,000 respondents. In Kenya, we estimate that a much smaller number of people are on Facebook, about 25% of the population, but we see a similar number of cellular subscriptions per capita. When we targeted people, we targeted them according to gender, and then we used sort of a narrower geographic targeting criteria. And in particular, we wanted to copy the geographic targeting strategy of the Afrobarometer, which is a nationally representative opinion survey. So we took the areas that were targeted by the Afrobarometer and sort of clustered them together, and then tried to collect Facebook respondents from within those clusters. We also added additional surveys that targeted people in underrepresented age and education strata. The survey in Kenya focused on demographics and political attitudes, and we recruited about 1,400 respondents. So here's an example of the ads that we used to recruit people in both countries, which would appear, for example, in their Facebook newsfeed. So to summarize the results, first we were interested in internal validity, and we basically examined two measures. The first was the targeting accuracy of the Facebook platform. So we looked at the percent of people whose self-reported characteristics on the survey matched the characteristics that were targeted by our Facebook ad. We found in the context of gender that the correspondence was quite good. So 98% of people in Mexico and 90% of people in Kenya self-reported a gender that was the same as the gender we had targeted with our Facebook ads. In terms of location, the performance was more variable. So 67% of people in Mexico and 63% of people in Kenya self-reported a location that matched their Facebook location. And then in terms of age, in Mexico, we found good performance. 87% of people reported an age that was consistent with the age category targeted by the ad that recruited them. But in Kenya, the performance of the age targeting was quite poor. So less than half of people self-reported an age that matched the category that targeted them. We then, as a second measure of internal validity, looked at attention checks. So in Kenya, encouragingly, we found that 98% of people could pass an easy attention check in which we simply asked their age twice and confirmed that the two numbers matched. Next, we looked at external validity. And in the context of demographics, we were interested in sort of comparing across 4 different groups. The first was the population of users on Facebook platform as a whole. And then we looked at the sample of people that we were able to recruit from within the Facebook platform. Relative to Facebook, we also considered the total population of people measured by the national census in both countries. And then we looked at these nationally representative opinion surveys, LAPUP and Afrobarometer. Here we're showing comparisons of these 4 different groups by age. We can see that in general, the Facebook population is much younger than the national population in both Mexico and Kenya. In Mexico, we stratified by age, and so our survey sample actually corrects this bias in the opposite direction. So we have more old respondents in Mexico than in the national population as a whole. In Kenya, since we didn't do explicit age stratification, we found that when we collected a survey sample, it actually exacerbated the existing bias on the platform. So the people we got in our survey sample were even younger than the average age on the platform. And in particular, we really had a hard time recruiting people over the age of 50. We also considered education. So we can see that in general, both Kenya and Mexico have pretty large numbers of people that are reporting that they have no more than a high school education, but that these people are underrepresented on the Facebook platform. And in particular, when we sample people, we tend to oversample people with higher levels of education. We also looked at opinion dimensions. So in Mexico, we asked people about how they valued environmental protection relative to economic growth. We found that on Facebook, people were more likely to emphasize environmental protection relative to growth, which suggests that they might be sort of more environmentally friendly or more environmentally conscious than the average population. In Kenya, we were looking at political attitudes and opinions. So as you might expect, the Facebook population was more politically engaged than the average Afrobarometer, nationally representative sample. So Facebook users were more likely to have protested or contacted the government or have voted. according to their self-reported behavior. But interestingly, we found that the Facebook sample was less likely to say that it was close to a particular political party. We also found that about equal numbers of people approved of the president and felt free to speak their mind in both countries. Finally, we considered the cost of running surveys. And as we expected, they are fairly low, but we did find a lot of variability in costs. And in particular, we found that costs heavily depended on the targeting criteria that we used. So in both countries, we were able to reach a pretty large audience in a matter of days, over 400,000 people with our ads in Mexico and over 300,000 people in Kenya. And we got a response rate hovering around 1%. The total spent for this number of responses and advertising costs was relatively low, so about $850 in recruitment costs in Mexico and about $1,300 in recruitment costs in Kenya. In Mexico, overall, the cost per survey was relatively affordable, between 7 and 55 cents per respondent recruited. In Kenya, on the other hand, we found some strata were very cheap to recruit, about 5 cents per respondent, but others were extremely expensive, so up to $22 per respondent in areas of the country where there are fewer Facebook users of the type that we were interested in recruiting. And we wound up actually stopping some of the ad campaigns when the cost became prohibitive. So this is sort of a conservative estimate of how much it could cost in advertising to recruit a single respondent in areas where there might be low population density or very low internet use. So I just wanted to conclude by sort of summarizing our findings. I'll say that I sort of entered this project as a skeptic, but over the course of conducting this research, I've sort of become convinced that Facebook is a great tool for diversifying survey audiences beyond traditional mechanical turk or undergraduate lab samples. We found that it's relatively cheap to recruit respondents basically in real time. So you can, overnight or over a weekend, you can recruit a couple hundred people to take your survey. And the targeting capabilities are pretty impressive. So you can get sort of really narrow strata of people to respond to your survey. And I think, again, given the context of the current pandemic, these capabilities are really valuable in the sense that we could reach different audiences. We could ask how they're doing, in terms of their health status, their economic well-being, and do this in many different countries, on a pretty feasible budget. On the flip side, I will say that, using online platforms really comes with clear costs. So on Facebook, we found that some strata, so some groups of people that we're interested in, we just could not reach them at all. So there are some people that are just not on Facebook, and then there's others that do appear to be on the Facebook platform, but did not respond to our survey ads. We also found that in order to gather certain populations of interest, we wound up paying very high advertising costs. So if you're really trying to target a narrow group of people, this might not be the most cost-effective strategy for you. Finally, we found that the accuracy of this targeting was also mixed. So in particular, people self-reported characteristics did not always match their Facebook-reported characteristics. Next, we also found pretty substantial selection bias in the people that responded to our survey. And they were biased with respect to the national sort of census population, but also with respect to the population of people on Facebook as a whole. And so we recommend that researchers that are interested in using this platform consider both of these populations as separate benchmarks. Currently, we're sort of experimenting with some stratification and post-adjustment techniques, but we found that we cannot fully address these biases using these techniques so far. So to conclude, essentially, the goal of this work has really been to sort of frame some of the considerations and trade-offs for researchers that are interested in this platform. And I think our team as a whole sort of hesitates to come down on the side of saying, Facebook surveys are always better than in-person surveys, are always worse. But rather, this is sort of a tool that you can consider as part of your arsenal. And having a good understanding of the limitations and the benefits will help you decide if this is sort of right for your project. I'll conclude with the list of my co-authors, and I think also linked here the paper and the online appendix, as well as some more details about our Kenya pilot. So I thank you for your attention during this presentation, and I hope to see you in the interactive Q&A session.
Hello, I'm Setia Pramana from BPS Statistik Indonesia. It's a great pleasure to be part of this 2020 Virtual United Nations World Data Forum. For today's talk, I was asked to discuss or to discuss about our innovative use of social media for remote sensing and SDG monitoring in Indonesia. These cases that I'm going to show is only part of the research or some cases that are being done right now in Indonesia for using big data for official statistics and also for public policy. So this is the outline of my presentations. So there are 4 cases that we are going to discuss and to share with you. For the first one is how we can infer a commuting pattern in Greater Jakarta for using social media and also for using location information for mobile device. And the second one, how we can use the geospatial data analysis from Instagram for tourism pattern. And the third case will be using online news and social media analysis for Indonesian tourism promotions. And the last cases is how to use the social media base for subjective happiness index. So the first case is using or implementing big data for predicting commuting pattern. In this case, we use Twitter. As we know that in Jakarta, we have around 10.7 million populations, and outside Jakarta, the Greater Jakarta is almost double of that numbers. So this large number of population that are commuting between Greater Jakarta and also between Jakarta and also outside Jakarta make Jakarta and also Greater Jakarta facing urban challenges such as transportation, traffic, and etc. In Indonesia right now, we have 175.4 million internet users, and then around 60 million are accessing social media for their daily use. Furthermore, Jakarta is often named as a Twitter capital, as these people post a lot of tweets per day, so around 10 million tweets per day. So the goal of this study is to investigate how the locational information from social media on mobile device can reveal the commuting patterns in Greater Jakarta. This work is in collaboration with the UN Global Post Lab Jakarta. So we compare 2 data sources. The first data source is from the Greater Jakarta Commuter Survey, which is done in 2014. So this survey have 13,000 households from 13 regencies, include 5 Jakarta cities, Central, South, Northeast, and West Jakarta, and also 5 satellite cities outskirts of Jakarta, Bogor, Bekasi, Depok, Tangerang, and South Jakarta, and also 3 regencies outside Jakarta. So this commuter survey is used as the ground check. So we compare with the Twitter data, which is obtained from January the 1st, 2014, into May 13th of 2014. All the tweets are basically based on GPS timed, and then we include only the tweets that are posted using mobile device. And these locations are then mapped into administrative resolutions. So we obtain the tweets that we obtain is around 38.5 tweets, million tweets, and then it's from 1.5 unique users. So the tweets are then we use these tweets, the geotag location of the tweeters, to infer the home location and also destinations. The home is inferred as the most tweeted sub-district location between 9 p.m. to 7 p.m. We expect that they are at home in this time. And then destination location is determined as the most tweeted sub-district location during weekdays, excluding home locations. Of course, we need to calibrate these numbers based on the number of population and also based on the number of penetration rate across the cities. The results as follows. We observe that this is the circus plot of the commuter survey and also the Twitter. The left hand side is from commuter survey and the right hand side is based on the Twitters. So these are the circles showing the commuting pattern between regencies and cities in Greater Jakarta. So the thickness of the line showing the large number of people moving from area to another area. We observe that from the left hand side to the right hand side, they have similar pattern between the commuter survey and also the Twitter data. And we also calculate the correlation. correlation is quite high, 0.97. So it's showing that our approach using Twitter data can have the same pattern as the computer survey is done. So the second case is by using Instagram. So we get the data from Instagram from December 2018 to March 2019 with several different keywords. For example, Wonderful Indonesia, Pesona Indonesia, or Indonesian tourisms. This aim to see how the tourism pattern in Indonesia. We obtained around 0.9 million posting, and then only 25% of it have a geotag, because not all tourists put their geotag on their posting and Instagram. And then after some pre-processing and also cleaning, we obtained 400,000 posting to be used for the analysis. So the analysis, the result of the analysis is as follows. We see the location are shown here, or the red dots here are the location of most visited locations in Indonesia. If you look at the main island, Java, have the most red dots here, because that is the main island and also most populated island in Indonesia. But there are also several locations. For example, if you see that in the east, you have Aceh, and so in the middle you have Medan, also Singapore there, but not Singapore means that also Batam, some of our island near Singapore, and also we have Padang. Also in Borneo, in Kalimantan, there are several tourism spots there, and also in Sulawesi, and also in Raja Ampat. If you see that Papua up to north, this is showing how the tourisms are pattern in Indonesia. We also, based on this Instagram data, we try to infer how the movement of the tourists. So for example, we take the tourists from one tourist spot to another tourist spot from different time. We can see how they move from one site to another sites, another locations. So the third case, we use the online news and social media to see how the Indonesian tourism's promotions. So this left plot showing the percentage of tourism from abroad to Indonesia from different continents, and also on the right hand is from the tweets that coming from different continents as well. We see that they are more or less the same percentage of the number of tweets from tourists from Asia, mostly from Asia, right, and followed by from tourists from Europe. The same like as the number of tourists come from abroad to Indonesia between these two different years. From the tweets, we can also see how the reactions of the tourists when they are in Indonesia or when they have been in Indonesia. Most of the tweets are positive, showing that our tourist industry have given a good sentiment for the tourist. And the fourth cases is how we can use the Twitter, the text of the Twitter. Before we use the geospatial, but not exactly the text. Based on the text, we try to infer the subjective happiness index. And also the data come from Twitter from between April to July 2018. We have 2.4 million Twitter for training analysis, and after that 10,000 Twitter for testing. The results showing that several provinces have not that good low happiness index as compared to others. Some province showing in the yellow here that the province that they are neutral, not that happy but not that sad. But we see that the green province showing that they are the happiest, or the most people, the province with the most happiest people in Indonesia. So we have shown 4 cases out of several cases being used for using social media. Of course, we also use social media for different purposes. For example, during this pandemic, COVID-19, we see how the reaction of the citizen into how our government handle COVID-19, and also how about the unemployment and also other things using social media. But it's only because of limited case we just showing 4 cases right now. But we have shown to you that social media can be used as a promising alternative for data sources for SDGs monitoring. And then, of course, there's still plenty of approaches need to study and to explore, including methods need to be developed and also improve. But we have to give you last remarks that this showing big data can be used for complementing official statistic, and of course the contribution of all stakeholders still are needed for this improvement. I think that's all for my presentation. Thank you very much for your attentions.
Hello, I'm Riddhi Kashyap from the University of Oxford, and today I'll present some of the work that I've done with collaborators looking at how we can monitor global digital gender inequalities using data from social media advertising platforms. Several of the SDGs, the Global Sustainable Development Goals, recognize the important role of internet and mobile phone technologies. One such example of this is SDG 5 on gender equality that pledges to enhance the use of information and communication technology to promote the empowerment of women. This acknowledgement is particularly important given that despite the proliferation of internet and mobile technologies across the world, digital gender inequalities persist, and according to the International Telecommunications Union, there are some 200 million fewer women online compared with men. A key barrier, however, to regularly tracking progress on digital gender inequalities is the lack of gender disaggregated data on internet and mobile phone access. There's limited country coverage of surveys that collect information on internet access and mobile access by gender of the user, and when survey data sources are available, they aren't regularly produced or collected. There's inconsistencies also across different data sources that impede cross-national or cross-temporal comparisons. Here's an example illustrating the data gap for internet use, gender gaps in internet use, and here we see a map showing the gender gaps in internet use from available survey data. Here, ITU surveys. It's available also on our website, digitalgendergaps.org. This shows the female-to-male ratio of internet access, so a value of 1 would be equality between men and women in internet access, and values lower than 1 suggest that women are much less likely to be online compared with men. We see there's a significant data gap on this indicator in Sub-Saharan Africa and in South Asia. So, can innovative forms of data available from social media platforms help us fill this data gap and better monitor the SDG 5 indicator linked to digital gender inequalities? That's what we look at in our work, drawing on advertisement audience estimates that are available from social media ad platforms. What are ad audience estimates? Ad audience estimates are essentially answering a question, which is how many users of X characteristics, whether that's gender, location, age, device type, are on a given platform. They're meant for potential advertisers who'd like to launch an ad on that platform to know what their audience size is. But from a social research perspective, they can be thought of as a kind of digital census of the user base of the online platform. They're aggregate data and anonymous data, and even though launching the ad costs money, before the ad is launched, querying how many users would comprise the audience size of that ad is free of cost. So here's an example from the Facebook Ads Manager. Facebook's ad platform is what we've used the most in a lot of our work on digital gender gaps, but the general idea is applicable also to other kinds of platforms that would also have their own unique type of ads manager. Here we see I've queried how many Facebook users are in Nigeria over the age of 18 who are men. Facebook's potential reach here is estimated to be 15 million people. Similarly, I've queried here how many women over the age of 18 are Facebook users in Nigeria. Potential reach is 9.1 million people. So using this aggregate information on Nigeria's Facebook population, we can compute a Facebook gender gap index, which is simply the female to male ratio of Facebook users divided by the female to male ratio of the population. Why is it that we are dividing by the ratio of the population? Because we're interested in digital gender inequalities rather than demographic gender imbalances in a given population. So, for example, in countries where there might be more men or more women, disproportionately so, because, for example, in Qatar, there are just many more men in the Qatari population because of sex-selective patterns of migration, labor migration. We see many more men there. We want to capture not just how many more men there are simply because of these demographic reasons, but actually how many more men there might be or how many more women there might be because of digital access or digital use of these platforms. Thus, we weight each of our Facebook gender gap indicators also by the ratio of the population. Similarly, now these are all indicators of Facebook users, and not all Facebook users are, of course, internet users. So, in order to see to what extent the Facebook gender gap index is capturing internet use inequalities or internet access gender gaps, we need to have some kind of ground truth indicator of internet access gender inequalities, which we then analyze the relationship between the Facebook gender gap index and the internet gender gap index to try and see to what extent can the Facebook gender gap index help us say something or predict the internet gender gap index. Similarly, we can also try and compute a mobile gender gap index from ground truth survey data sources that are available to compute this indicator and then analyze the relationship between the population of Facebook users or gender gaps computed on Facebook users who are mobile users and see to what extent that can help us predict gender gaps of mobile access more generally. So, as I said, even though the Facebook ad platform is giving us information on Facebook users and the gender composition of Facebook users, we actually find that they're remarkably strongly correlated. The Facebook gender gap index and the ITU internet gender gap index, which is computed using available survey data for a given country. The correlation is strong and robust, and it's actually stronger than any other development indicator, including internet penetration, that we can compare against. This shows that there is really added value that these online indicators computed using the ad platforms of social media ad platforms are providing in coverage of this important development indicator. So here we can see gender gaps in internet use that have been predicted using the Facebook gender gap index, and further details of the approach are described on our website, digitalgendergaps.org, where we regularly query Facebook data, and then we use this to predict internet gender gaps across different countries in the world, as well as mobile gender gaps across different countries of the world. We further find that even though the Facebook gender gap index itself is quite strongly correlated and predictive of internet gender gap index, its predictive performance can actually be improved when it's combined with other development indicators such as the Human Development Index. However, using both offline and online variables or indicators together for this prediction task results in poorer country coverage than just simply using the Facebook gender gap indicator alone. And as a result, if you want to compare the different approaches that can also be done on our website, as well as the explanation of the different kinds of predictive models used to estimate internet access and mobile access inequalities, are described both on our website as well as the paper that presents our approach, published in World Development in 2018. So as I said, social media ad platforms in general, different social media and large online platforms, all of them have their ad platforms. So Facebook in this sense is not unique, although in our work we've used the Facebook ad platform the most to understand its potential. A similar approach is also possible using Google's ad platform, AdWords. Google as well is a very large online platform that has a large number of users and good demographic coverage across the world's population. When we compare gender gaps computed on Facebook's ad platforms versus Google's AdWords platform, we find that both of them do reasonably well. In fact, both of them do quite well, but Facebook does slightly better. So Facebook is independently better at predicting internet access gender gaps than AdWords platforms. However, the best performing models are actually those that combine Facebook and AdWords gender gaps. So that's interesting to know and potentially suggests to us that in future work, as we could, if say one platform experiences significant changes in behavior, the other one might act as a guard and protect and keep our model predictions reasonably stable. So we have two large online platforms with a large number of users across the world, and their good coverage allows us to make reasonably good predictions about internet access, gender inequalities. So to conclude, ad audience estimates is the innovative source of social media data that I've talked about today that are really valuable to measure digital gender gaps. They expand geographical coverage for an SDG indicator for which there are significant data gaps in conventional data sources such as surveys. They have finer temporal resolution. They can be queried regularly, although not historic estimate, or not in the past. We don't have historic estimates for any of these social media from these social media ad platforms. They also provide good spatial resolution, although most of the work that I've talked about today focuses only on national level estimates or country level estimates. They're a good complement to survey data, but it's important to note that they are not substituting them. In fact, we use survey data also to ground truth our Facebook gender gap and AdWords gender gap indicators to actually analyze what it is that they're helping us eventually predict is internet access gender gaps that we're computing using available survey data. Extensions of this work include the potential to monitor subnational digital gender gaps, so essentially going to local geographies to understand how are digital gender inequalities there. They can also help us as we collect this information over time, what factors contribute to digital gender gaps changing over time. For example, could policy interventions affect digital gender gaps and close them? These are the kinds of questions that this data source could help us evaluate, such as, for example, what happens when there are global crises such as COVID-19? How does that affect digital gender inequality? These are the kinds of questions, the effects of shocks and crises, or the effects of specific policy interventions. How do they affect digital gender inequalities? Are the kinds of questions that these data sources can help us address. Here are two key references where the approach that I've talked about today are described in greater detail, so please feel free to refer to them. And lastly, I'd like to acknowledge that this work is done in collaboration with a number of individuals from both computer science and social science backgrounds whose names are noted here. Please learn more about our approach and our work at digitalgendergaps.org, and feel free to reach out with any questions at rithi.kashyap@nuffield.ox.ac.uk. Thank you.
Hello, my name is Lisa Singh. I'm a professor in the Department of Computer Science and a research professor at the Massive Data Institute at Georgetown University. Today I will be talking about how we can blend noisy social media signals with traditional movement variables to help with early warning of forced migration. As all of you know, we are now witnessing the highest levels of displacement on record. Approximately 71 million people around the world have been forced from their homes, and this number is continuing to increase in our new COVID-19 world. The specific prediction task we are interested in is to determine when, where, and how many people will move from one location to another. If we could survey everyone in the world every day, we might have the data necessary to answer these questions with high accuracy, reliability, and limited bias. Unfortunately, these data do not exist. So we need to think about new forms of data that we can use to identify both direct and indirect indicators of movement. Organic data are an important new source of information for social scientists and policymakers who want to characterize and predict human and societal dynamics. So at a high level, the question we are interested in answering is the following. How can we responsibly use or blend new forms of data with traditional administrative and survey data to improve early warning of forced migration? Our high-level methodology is shown on this slide. We begin by identifying factors that impact a family's decision to move. We then identify traditional data sources used in the movement literature and determine how reliable they are. Next, we use open data sources, looking for both indirect and direct indicators of movement that we may not have sufficient data for from traditional sources. Here is where social media data comes in. We construct a number of variables and determine which ones can serve as proxies for movement factors. We then construct our model and validate it. Identifying relevant factors is a complex task and can be time-consuming if it is completed in isolation for each potential region of conflict. Social scientists on our team worked to develop an adaptable decision model for movement that incorporates the different theories of the causal factors of why people move in different situations. The goal was to develop a single model that incorporated all the factors and adjust or weight the model for different regions of the world. Toward that end, this model incorporates macro, meso or intervening, and micro drivers. It connects those different drivers to insecurities, environmental contexts, and feasibilities as influences into the final decision-making process. While this model is easily translatable into different mathematical models, getting all the variables for each factor associated with movement is next to impossible, even for a single conflict. Therefore, we have to leverage the available data and consider if social media, newspaper, and other organic data can be used as indirect indicators of some of these factors. In this work, we will see it is possible to use these new forms of data to predict movement in Iraq. We mapped the factors on the previous slide to 4 types of variables: traditional standard design variables and big data variables. Examples of standard design variables include unemployment rate, population data, ethnic diversity information, and terrain data. For our big data variables, we construct 3 types of variables for each factor: perception variables, including sentiment, emotion, and stance; buzz variables, such as conversation volume and topic volume; and event variables, such as political event counts. We determine the changing dynamics of these different variables. For example, conversation about violence may be an indirect indicator of death rate. Since death rate is a lagging indicator of movement, we're interested in seeing if this online conversation can serve as a proxy for death or for a different traditional indicator of movement. Therefore, an important goal is to determine the relationship between big data variables and traditional movement variables. So for our case study, we will look at Iraq from 2015 to 2017. We use our methodology to predict movement to different locations in Iraq at a given time. We consider 3 different data sets in our analysis. One data set contains traditional administrative variables collected from NGOs and government agencies. A second data set contains big data and organic variables. Specifically, we use tweets from Twitter and newspaper articles. The data is in both English and Arabic. And then we have a data set that combines the administrative and big data variables. We compare these different groupings of variables using multiple hierarchical Bayesian models and validate the accuracy of our predicted results using IOM data. We lag all the traditional and big data variables by 2 weeks so we can see if they are leading indicators to predict current movements. There are a lot of choices for modeling complex dynamic systems. The two we're exploring are hierarchical Bayesian models and agent-based models. I will focus on hierarchical Bayesian models today. We use the Bayesian approach for many reasons, but one of the main reasons is because of the temporal and spatial variation in the data. Hierarchical models allow us to incorporate data at multiple levels of analysis without repeating observations. Bayesian estimation of mixed hierarchical models makes specifying complex dependency structures between these levels of data explicit, which is important. Because we are predicting counts, we'll compare the following 3 count models: the negative binomial, the zero-inflated Poisson, the zero-inflated negative binomial. The negative binomial is effective for capturing over-dispersion of outcome variables by not forcing the mean and variance to be the same, like the Poisson. And because large-scale movement doesn't tend to happen all over the country at the same time, we have a large number of zeros, and we want to consider models that account for this. While different hierarchical Bayesian models perform well, the zero-inflated negative binomial with a CAR term performs the best. This plot shows the CDF and shows very strong results for all of our dataset combinations. Traditional variables perform better than big data variables, but the big data variables perform very well. Moreover, blending traditional variables, which we have access to, with variables constructed from social media and newspaper data improves performance across all of the different conditions. These figures include both Arabic and English data, but using either alone performs similarly. In some ways, this result is misleading. Of course, we would expect the results to be strong because there are so many zeros in the prediction results. Most of the origin-destination pairs have zero movement. So we decide to focus in on larger movement predictions. Here we focus in on large movements where a movement is considered large if it is in at least the 75th percentile in the overall movement for a particular district destination. Using our model, we compute the precision recall and F1 scores for estimating large movements to destination districts. We see that the traditional and the Arabic blended models perform the best, and the big data only model is comparable. One thing that stands out is the significance of death counts in the traditional variable set. Because death counts are typically not available during conflict, we also run our model using the traditional variables except for death count. We find that using other traditional variables alone are not as useful for this movement case, again highlighting the potential for big data. To give you a little intuition as to why the big data variables perform so well, we look at the coefficient estimates of 2 variables, death and events count. Among traditional variables, death is the strongest signal for movement. However, death is a lagging indicator. Event count is one of the big data variables that is also a strong predictor. In some sense, it serves as a leading indirect indicator of death. This variable, along with violence conversation in Arabic, are 2 of the strongest big data variables for this case study. Our goal is to augment traditional domain data with open source big data to predict forced migration and lay the groundwork for studying forced migration and early warning. We extract unique variables from Twitter and EOS newspaper data and continue to understand the relationship between these variables, R factors, and forced migration. We've demonstrated the value of incorporating big data variables in predicting forced migration in the context of Iraq, and are now extending this work to investigate movement in South America, specifically Venezuela. There's no doubt that using social media has limitations, but when blended with other sources, it can give important insight when data gaps exist. When we are investigating problems that are global in nature, we very quickly see that different places have different types of available data at different temporal and spatial scales and at different levels of quality. Therefore, if we're going to be robust, we need to think about methodologies for using any available data and compensating for noise, bias, non-representativeness, etc. I want to thank the team that works on this with me, and I would like to thank those who have supported this research. Thank you all for listening.